हरि करना।
Now let's deep dive into the discrete random variables. Discrete random variables. So a discrete random variable is a type of random variable that takes on a finite or countably infinite number of possible values. So each with a certain probability of occurrence. In other words, a discrete random variable can only take on specific numerical values, and the probabilities associated with those values can be determined based on the probability distribution of the variables. So for discrete random variable, so let's say the random variable is denoted as capital X, a discrete random variable. So now probability P, probability of small x denotes, you can also denote probability of random variable at value or at individual outcome small x. I hope you got how to read this. When we say either probability of x also can be denoted as probability of capital X is equals to X. This means probability of random variable capital X at the individual outcome of small x or individual value of small x. Or you can say that probability that capital X when the random variable is small x. Okay, small x is nothing but individual value, individual value. Then probability of capital X is called the probability of mass function. When you say P of capital X without mentioning any small x values, any values, then that's what we call it as a probability mass function, PMF. PMF. So probability of mass function of a random variable x, capital X. So P of capital X is called the probability mass function of random variable capital X. So P of small x or P of capital X is equals to small x is the value of the probability mass function at small x. That's what I'm trying to say. So this is how we represent the probability distribution of a discrete random variables. So in this, the properties of this discrete random variables distribution is pretty simple. Probability of small x should always be greater than or equals to 0, and it should always be less than or equals to 1. So the probability of each outcome in between in that distribution should never be lesser than 0 or greater than 1. It should always be in between 0 and 1, or it could be 0 or 1, and it should be in between 0 and 1. So these are the two initial properties, and after that, if you do the summation of probability of each individual value in that distribution, it should come to the 1, it should count to the 1, it should come to the 1, the summation should be 1. So these are the three important properties of discrete random variable probability mass function. Okay, so now let's see some examples of discrete random variables include number of children in a family. So this variable can take on any values such as 0, 1, 2, 3, etc. The probability of each value depends on the probability distribution of family sizes in the population. And second example, number of cars sold in a month. This variable can take on values such as 0, 1, 2, 3, etc. The probability of each value depends on the sales data for a specific car dealership. Then one more example for discrete random variables is number of heads in multiple coin tosses, and one more is number of customers who enter a store in in an r in an r. So this variable can take on a values such as 0, 1, 2, 3, etc. The probability of each value depends on the foot traffic in the area, time of the day, and other factors. So discrete random variables are often used in statistical analysis and modeling in many fields, including finance, engineering, and social sciences. Some common probability distributions used for discrete random variables include the binomial distribution, Poisson distribution, geometric distribution. In summary, a discrete random variable is a variable that takes on a finite or countably infinite number of possible values, each with a certain probability of occurrence. Understanding discrete random variables is important for statistical analysis and modeling in many fields.